Today we're going to learn about polynomial inequalities, and your learning goal is that you'll be able to find the zeros of a polynomial and use the shape, which is like the and behavior, and the zeros to write the solution of an inequality. So we're going to use what we've learned about factoring and graphing polynomials to help us solve polynomial inequalities. So the first thing you want to do is find your zeros. So you're going to set this equal to 0. And we're going to find our zeros. I'm going to find two factors of negative 30 that give me 13. So that will be positive 15 and negative 2. And it doesn't matter which order you put the 15 and negative 2. Then I'm going to do grouping. So I'm going to take out a negative 1. And I'm going to set each one equal to 0. So x would be 1/3 and negative 5/2. So my zeros would be 1/3 0 and negative 5/2 0. Since this is a positive even, that means that my and behavior is going to be, as x approaches negative infinity, f of x approaches negative infinity, as x, I forgot the x, as x approaches positive infinity, was supposed to be positive infinity. As x approaches positive infinity, f of x approaches positive infinity. Okay? So when we graph it, here's 1/3 0, and here's negative 5/2 0. And my y-intercept is at 0, negative 5. So it looks something like this shape. Okay, so to find the solution, what this is saying, this inequality is saying that the polynomial is greater than 0 where the graph is above the x-axis, because it says this is greater than 0. And so you look at your graph and you're looking for those values where x is, or where your y values are greater than 0. So here's negative 5/2, use a different color. So from negative 5/2 to positive 1/3, all your y values are below 0. That means that you're going to, the only places where your x values are, or your y values are greater than 0 would be all your x values smaller than negative 5/2, or all your x values greater than 1/3. So anything outside of those, and this is how we write it: negative infinity to negative 5/2, union 1/3 to infinity. So those are the only intervals or x values that fit the description that you're looking for anything greater than 0. Okay, for this particular problem, finding the zeros would require us, first of all, using the fundamental theorem of algebra. So that means that we have to make our list of possibles. So all the factors of 6. Divided by all the factors of 12. So I'm going to get, this is my list. Dividing each one by one. So I got 1, 2, 3, and then 6. Then I have 1/2, 1/3, 1/4, 1/6, and 1 1/4, 1/6, 1/12. Then I'm going to do 2. So I got 2 over 1, 2 over 2. If you see anything repeated, you don't have to list it more than once. 2/3, 2/4 I already have, 2/6 I have, 2/12 I have. Then I have 3, 3/2, 3 over 3 I have, 3/4, 3/6 I have, 3/12 I have. Then I have to do 6. 6 over 1, 6 over 2, 6 over 3, 6 over 4, 6, 6, 6/12. So I have all of those. And then you test it out. I'm going to try -1. And I look, no terms are missing. Bring down to 12. Just keep doing synthetic, hoping you were a good guesser. And we were. And this can be factored. 2 factors of -72. They give you -1. So that's -9x and 8x. So I'm going to take out a 3. And then here I'm going to take out a 2. So I have 3x plus 2, 4x minus 3, setting each one equal to 0, and get -2/3 and 3/4. So my zeros are -1, 0, -2/3, 0, and 3/4, 0. Since this is a positive odd, my end behavior is as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. So when you graph it, oh, and all of these have a multiplicity of 1. I forgot to state that on the other one. Okay. So when you graph it, we have negative 1, 0, negative 2/3, and then 3/4, 0. And I'm just going to follow my end behavior and just do a sketch. And then hit the y-axis at 0, negative 6. Okay, so here we're looking for all the x values that are smaller than 0. So if you notice, anything to the left of negative 1, the y values would be smaller. Anything between negative 2/3 and 3/4, all my y values are smaller than 0. And anything else in between or outside of that will not work. So when you write your solution, since this is a less than, that's an and, you write negative infinity to negative 1 and negative 2/3 to 3/4. And then you're done.